Okay, let's switch from alkyl halides to our next group of compounds that are called ethers. So an ether has an oxygen that is bonded to two alkyl groups. If the alkyl groups are the same, so in this generic structure just R, okay, we can call that a symmetrical ether. If the alkyl groups are different, like R prime and R, that is obviously an unsymmetrical ether. Okay, some real examples would be these two shown here. Okay, and with those I'm going to show you how to use common naming to name ethers. So this is a symmetrical ether, and then we have two methyl groups. We would simply name it dimethyl ether. The other one's a little bit harder to see, and I did that on purpose to try and help you remember your common substituents. If we expand this out, it becomes a little bit easier. You can see that this carbon that's bonded to the oxygen is a tertiary carbon bonded to three other carbons, and there's four total. So that's a tert-butyl group. Over here, this is the isopropyl group. So if we put it together, it's tert-butyl isopropyl ether. Okay, now let's talk about the IUPAC naming of ethers. So what we're going to do here is we're going to treat the ether portion off the parent chain as a substituent. Usually if our substituent was a methyl group, we would say 1-methyl or 2-methyl. Now, since it's an ether, we're going to replace the YL portion of methyl or ethyl with OXE, so that we let everyone know that it's not an alkyl substituent, but an ether substituent. For example, if this was our substituent OCH3, it would be methoxy. If we have an ether with 1, 2, 3, 4, it would be, with 4 carbons, it would be butoxy. So here's an example. I've numbered my longest carbon chain here. 1, 2, 3, 4, 5. I started here at carbon number 1 instead of here because my first substituent is the ether portion. On carbon number 1, then at 2 I have a methyl group. So if we put it all together, it's 1 isopropoxy. So instead of isopropyl, I did isopropoxy 2-methyl pentane.